Probiotic bacteria. What is their role in water reservoirs? Probiotic bacteria, although we associate them more often with food products than with water reservoirs, play an extremely important role in maintaining biological balance also in various ecosystems. In water reservoirs, both natural and artificial, they constitute an important part of the microflora, affecting the health and functioning of organisms inhabiting these environments. Freshwater reservoirs, such as lakes, rivers and ponds, are inhabited by many species of probiotic bacteria. By their participation in the circulation of nutrients, they contribute to the maintenance of the biological cycle. These bacteria play a key role in nitrogen transformations, i.e., denitrification and nitrification, which helps maintain the nitrogen balance in the tank. In addition, they accelerate the decomposition of organic substances, thus helping to control organic pollutants. In artificial water reservoirs, such as freshwater aquariums, probiotic bacteria perform similar functions as in the natural environment. Among other things, they maintain the biological balance of the aquarium by converting fish metabolic products, such as ammonia and nitrites, into less harmful compounds. In addition, in aquariums, probiotic bacteria can serve as a dietary supplement for aquatic organisms. Their additional use is to protect fish from diseases by improving immunity, as well as creating competition for pathogenic bacteria in the fight for resources, which limits their development and spread. In marine ecosystems, probiotic bacteria are as important as in freshwater. They act as an essential element of the food web, converting organic matter into inorganic compounds that can be used by phytoplankton. Thus, they provide the basis for the food chain, sustaining the life of a variety of marine species, from microscopic organisms to larger marine animals. As in the case of freshwater tanks, probiotics in marine aquariums play an essential role. They create an extremely important element of the biological balance of marine aquariums, affecting the quality of water, the health of fish and other marine creatures. As mentioned earlier, probiotic bacteria are involved in key biochemical processes, such as nitrification and denitrification, converting toxic substances such as ammonia or nitrites into less harmful nitrogen compounds. Thanks to this, in a salty environment, they provide safe living conditions for marine organisms, such as fish, corals and invertebrates. In marine aquariums, probiotic bacteria can act as an important food source for certain organisms, such as corals, that use them to supplement their diet. As you can see, probiotic bacteria in water reservoirs are extremely useful. They perform many important functions, supporting the development of a beautiful and healthy environment. Importantly, the presence of bacteria is indicated both in natural tanks and in aquariums. Pigs can transmit dangerous superbugs to humans. Scientists have found evidence that dangerous superbugs can spread from pigs to humans. These findings underscore concerns that the heavy use of antibiotics in animal husbandry is leading to the spread of antibiotic-resistant microbes. In samples of the superbug Clostridioides difficile taken from 14 pig farms in Denmark, multiple antibiotic resistance genes were found to coexist in pigs and humans. This provides evidence that superbugs can be transmitted from animals to humans. The study, conducted by Dr. Seme Bajawi and her colleagues at the University of Copenhagen and Statens Serum Institute in Denmark, was presented at this year's European Congress of Clinical Microbiology and Infectious Diseases, ECCMID, in Lisbon. The shared genes we discovered indicate that C. difficile is a reservoir of antimicrobial resistance genes that can be exchanged between animals and humans, says Dr. Bajawi. This worrying finding suggests that antibiotic resistance may be spreading more widely than previously thought. This also confirms the existence of links in the chain of resistance leading from farm animals to humans, he adds. C. difficile is a bacterium that infects the human intestines, and only 3 antibiotics currently in use can deal with it. Some strains of bacteria contain genes that enable them to produce toxins that can cause harmful inflammation in the gut, leading to life-threatening diarrhea. Mainly in elderly people and hospitalized patients who have been treated with antibiotics. C. difficile is considered one of the greatest threats related to antibiotic resistance. In the United States alone, in 2017, it caused 223,900 infections and 12,800 deaths, and the healthcare costs of patients amounted to over $1 billion. The infectious strain of C. difficile, which can cause more serious diseases, and its main sequence type 11, ST11, are associated with an increasing number of infections in young and healthy people. Livestock have recently been identified as reservoirs of this strain. In their work, Danish scientists studied the prevalence of C. difficile strains in farm animals, pigs, and the possibility of zoonotic spread of antimicrobial resistance genes. Fecal samples were collected from 514 pigs on farms across Denmark in 2020-2021. They were tested for C. difficile, and genetic sequencing was used to determine if they contained genes for resistance to toxins and drugs. Genome sequencing was also used to compare samples taken from Danish hospital patients with C. difficile infection during the same period. A total of 13 sequence types found in animals matched those found in human samples. In 16 cases, the ST11 strains in humans and animals were identical. All of the animal isolates were positive for the toxin genes, and 10 of them were even more disease-causing. The excessive use of antibiotics in human medicine and as cheap production tools on farms undermines our ability to treat bacterial infections, said Dr. Bajawi. Particularly worrying is the large pool of genes conferring resistance to aminoglycosides, a class of antibiotics to which C. difficile is intrinsically resistant. They are not needed to generate resistance in this species. C. difficile therefore plays a role in spreading these genes to other susceptible species. He explains. This study provides further evidence of evolutionary pressures associated with the use of antimicrobials in animal husbandry, leading to the selection of dangerous, resistant human pathogens. This highlights the need for a more comprehensive approach to the treatment of C. difficile infection to address all possible routes of infection and antibiotic resistance, adds Dr. Bajawi. Google confirms quantum supremacy. 10,000 years of calculations in 200 seconds created by scientists from Google. The Sycamore computer seems to be a long-awaited breakthrough in the field of quantum computing. Google engineers say their quantum computer solved a problem that would take even the best conventional machines thousands of years in just over 3 minutes. This is the beginning of a new era of computers. Google engineers have reached a milestone, taking a long-awaited step towards the realization of quantum computers. devices that use strange properties of quantum physics to speed up certain calculations. The publication describing the achievements of engineers employed by the technological giant appeared in the journal Nature in September 2019. An article describing the details of work on the quantum computer of Google scientists appeared on NASA servers, but it was quickly deleted. However, as we all know, nothing is lost on the internet. The description of the works has been made available on other servers. Google did not comment on the media reports at the time. In October 2019, the official version of the article was published in a prestigious, peer-reviewed journal. It seems to contain no significant changes from the text that accidentally saw the light of day. He points out that the Sycamore computer's quantum processor, consisting of 54 superconducting quantum bits, or qubits, was able to perform calculations that far exceed the capabilities of even the world's fastest computer. The experiment with a quantum processor, described in Nature, involved performing random operations on qubits and reading the result. The set of digits encoded in the binary system generated in this way was checked whether the distribution is truly random. These calculations are not particularly useful, but have large implications for the processing power of the device. Performing such calculations is extremely difficult to reproduce with a classical computer. It had previously been estimated that IBM's fastest conventional computer, Summit, would take 10,000 hours to complete the task. Years. Sycamore did it in 3 minutes and 20 seconds, although one of the qubits had to be disabled because it wasn't working properly. Sycamore was developed by engineers led by John Martinez, an experimental physicist at the University of California, Santa Barbara, also employed by Google. Quantum supremacy has long been considered a milestone because it proves that quantum computers can surpass classical computers. While the advantage has only been proven in a very specific case, it does show that quantum mechanics works as expected when used in a complex problem. While the calculation Google has chosen, checking the results of a quantum random number generator, has limited practical applications, the scientific achievement is huge, said Scott Aronson, a computer scientist at the University of Texas at Austin. Google's achievements do not mean that quantum computers are ready to solve real-world problems. There is still a long way to go. However, it is a proof of concept and the first step towards developing useful quantum computers. IBM, Google's competitor in building quantum computers, announced that its Summit machine, thanks to new software, is capable of performing similar calculations in 2.5 days. These claims have not been verified by independent scientists, and the description has not appeared in any scientific journal. IBM has its own quantum computer called Q System 1. Traditional computers perform calculations on bits, series of zeros and ones. Their quantum counterparts use qubits, or quantum bits, and these can take on both at the same time. The Sycamore processor consists of 142 qubits, but only 54 are controlled, actually 53. Because one of them is not working properly. Google is working on other configurations, but the current one, the researchers say, was the most suitable for conducting an experiment proving quantum supremacy. Google's achievements are the beginning of a new era of quantum computing. Quantum computing can change the way we design new materials, manage logistics, build artificial intelligence and break codes. That is why companies such as Google, Intel and IBM allocate millions to build a quantum computer.